Phoenix Mars lander sends back picture of Martian dust. The image is a higher magnification than anything ever seen from another planet. A new first. NASA's Mars Phoenix lander has sent back the first ever image of a speck of red Martian dust taken through an atomic force microscope, shown at a much higher magnification than anything ever seen from another planet. The dust particle is approximately 1 micrometer, or 1/1,000,000th of a meter, across, and is representative of the dust that cloaks Mars, producing the planet's distinctive red soil and coloring it sky pink, NASA has reported. This is the first picture of a clay-sized particle on Mars, and the size agrees with predictions from the colors seen in sunsets on the red planet. Said a Phoenix co-investigator. Phoenix has been exploring the Martian Arctic Circle since May 25th and has already provided definitive proof that ice and water exist on Earth's planetary neighbor. Yes, and water is life. All life comes from water, and without no water there is no life. And water is the spirit of the living God, the Creator. It has a consciousness in some kind of way. It is the latest NASA spacecraft sent to Mars as the space agency tries to determine if life, even little microbes, exists or ever existed there. The new pictures were taken using Phoenix's onboard atomic force microscope, which maps the particles in 3 dimensions and can detail shapes as small as 1/1000th the width of a human hair, or 100 times greater magnification than the lander's optical microscope. And until now, the spacecraft's optical microscope had held the record for producing the most highly magnified images from another planet so far. This is proof of the microscope's potential. We are now ready to start doing scientific experiments that will add a new dimension to measurements being made by other Phoenix lander instruments. Yes, water is life. So, in essence, life has been found on another planet. Because, like I say, you have to have water in order to have life. Melting glaciers likely made Mars gullies. Evidence suggests Mars was once much wetter than it is now. The gullies that cut the sides of Martian craters were likely formed by meltwater from glaciers that existed just a few million years ago, when Mars was wetter than it is now. A new study suggests. The gully features are similar to ones seen in the dry valleys of Antarctica, say the authors of the study, which is detailed in the August 25th issue of the journal Proceedings of the National Academy of Sciences. So this polar region of Earth can act as an analog, or as an example for Mars' past. The gullies, young features, geologically speaking, were discovered in 2000 by NASA's orbiting Mars Global Surveyor. The discovery came as a surprise, because scientists and researchers had thought that Mars was too dry in the past few million years to host liquid water at its surface. Although water ice was confirmed this summer by NASA's Phoenix Mars lander just a few inches below the surface of Mars' Arctic regions, the planet's below freezing temperatures and low atmospheric pressure ensure that any ice exposed to the air turns into vapor. When the gullies were discovered, some scientists proposed that the features were formed either by dry avalanches or by groundwater pushing up from below the surface and running down the sides of craters. But in a study of gullies within a 6.5 mile, 10.5 kilometer diameter crater located in the much larger Newton crater, James Head of Brown University and his colleagues have found that accumulated ice and snow were more likely the source of the water that made the gullies. Ice ages. James Head and his team examined high-resolution images of the crater and its gullies taken by orbiting spacecraft and found evidence of features that suggested glaciers once covered the crater floor approximately 10 million to 20 million years ago. As Mars' orbit and planetary tilt with respect to the Sun changed as a result of the natural wobble of the planet's axis, the glaciers went away or evaporated, and the bulk of the ice was lost. As the ice started to vaporize, debris embedded within it began to pile up on the crater floor. These deposits can be seen on the crater floors now. But debris didn't accumulate as much on the crater walls, leaving behind hollows where the glaciers once sat. Where the ice used to stand, you now have holes. As the climate continued to change, not enough snow fell to maintain the glaciers, and the holes left by the glaciers could have caught wind-blown snow and preserved it in drifts. In the summer, these drifts were likely exposed to warmer summer temperatures, melting the snow and ice deposits, which then in turn ran down the crater slopes, eroding the sediment or the dirt and forming the channels and fans of the gullies. Because this new study, funded by NASA and the National Science Foundation, shows that glaciers pre-existed the gullies, it seems likely that melting snow and ice are behind the gully formations. Well, this is a cycle that's been going on a long time, just like here on Earth. We have ice ages, and then it gets warm again. Well, the present cycle excluded, of course. Mars ice clouds eat up ozone. New study gives scientists new clues about the climate environment of the red planet. Clouds of water ice drifting above the Martian surface eat up some of the ozone in Mars' atmosphere, a new study suggests, giving scientists and researchers new clues about the chemical environment and climate of Earth's nearest neighbor. Earth is different than Mars, although there is similarities. Mars has a relatively stable atmosphere that is 95% carbon dioxide. Earth's atmosphere, in contrast, is only 0.04% carbon dioxide. Scientists have had a difficult time modeling certain aspects of Mars' atmosphere, and some suspect that reactions between atmospheric gases and ice cloud particles could account for the differences between their models and satellite observations, particularly of ozone concentrations, although there's still a lot about Mars that we don't know. Water ice clouds high in Earth's atmosphere are key factors in the loss of ozone above the poles and may change the chemistry and layers of air below. Likewise, some scientists thought similar clouds on Mars could be affecting ozone levels in Mars' atmosphere. Anyway, yes, Mars is the next frontier. It's part of the future of mankind, humankind. But yes, first, we must learn how to preserve the planet Earth, the mother world, the home world. We must always have Earth to return to, or Eden. Yes, we must always have an Eden to come back to. So first, we have to get past these challenges that are now upon us in these end times, transition days. And yes, Mars is part of our future.